Continuing on to part 2 now of this video, flipped classroom video, I'd like you to include this now in your flipped classroom video notebook. This will be a skill check. This is something that's new with this book, and again, there's only 4 sections, although they seem like long sections, and we have plenty of time. So write this out. And what they want you to find is the union of M and N, and then the intersection with K. So here's the data. Write it out and pause it, and in a moment we'll give you the results. And this is the answer. So, check your work. This is a good way to get some hands-on experience. Be sure you know what's going on. All right, well, let's continue. We're going on to another kind of set, and we did mention this earlier, too. This is when set A and set B are a disjoint set. That is, there are no elements common to both sets. And again, this gives us what is called an empty set, or a new word, again, this was mentioned earlier, a null set. And we know another way to indicate that would be braces with nothing inside the braces. Okay, so let's take a look at this one here. This is set U, the universe, all students. Set A, students with a GPA under 2.5. And then set B, students with a GPA over 3.0. So notice there wouldn't be any students in set A that would be in set B, or any students in set B that would be in set A. Therefore, this is a disjoint, and in looking at it in a Venn diagram, would look like so. So again, they're starting us off with something very easy. Now, something they're going to bring up here shortly that is also for background information. So this is something you would include in your notes as a background item. And here's a new symbol here. Now, this is the symbol for A, this is the symbol for B, this is the symbol for the universe. Now, the symbol for A, with like a little slash, it's not a exponent, it's not a 1, it's like a little slash there. This is red, A prime, or I like this one better, A complement. So what is the complement of A in this diagram? Well, I'll shade it for you here a little bit. Let's see if I can get something going here. And let's get it a little bit bigger here too. A complement would be anything in the universe. Let's make it bigger than that too. Oh, I have to undo that here because I don't want to do that. Okay. So it'd be anything in the universe that is not in A. So all of this now, this part here would be A complement. So we're just using this Venn diagram to illustrate this. This is a disjoint as it appeared originally, but I'm showing you now what A complement is. What is A complement? Anything in the universe that is not in A. So we'll be using that here shortly. Okay. So we're jumping in here to what is called De Morgan's law. Now, looking at De Morgan's law, unfortunately you're going to have to memorize this. Let me work it out for you. What does this say here first? It's set A in union with set B, but it's the complement of this. So let me show you what that looks like and take these notes. So we're going to have the union now of set A and set B, and I'll just color them in. Let's see, I don't want that dark color there. Let me erase this part here. There we go. This is set B, and I'm going to color this in here. Up. So this is set B. So I'm indicating in a Venn diagram set A that I've colored in union with set B that I've colored in. So this is the representation of set A and set B. But now we're looking for the complement of this. So what would the complement of this be? Well, it would be all of this out here. This is represented by this white area. That is the complement of the union of set A and B. Now, let me draw this for you point by point and see if it looks like this at the end. Again, we're looking for the white area. Now, what we want to do now is to sketch in the complement of A. So for that, we have to take everything that is not in A, and we're coloring it yellow here. All right, that's what the complement of A now is, this part right here. That's the yellow part. Now I'm going to sketch in the complement of B. So the complement of B would be anything that's not in B. So of course we have to color over all of this yellow here and all of this. Okay, now do you see what is the intersection of these? Well, the intersection would be where both the yellow and the blue are. So that is this white area in this diagram and the blue and yellow area in this diagram. So the parts that are not colored both yellow and blue are set A and are set B. So we see then in De Morgan's law that this is true. The complement of the union of A and B is equal to the intersections of the complements of A and the complement of B. Now, a converse of that, where if you took the intersection of set A and set B's complement, that would be equivalent to the union of the complement of A and the complement of B. So it's just sort of, if you remember this one changes by going from union to intersection, and this one changes from intersection to union, and they show the same thing. So this is De Morgan's law. Now, initially you're going to use your notes to do work on this. And on the test, I'm not sure whether you can use, I don't think you can use notes, but we'll see. You may not have one like this on your test. Okay, well, let's go on to see what they're going to ask us about this. Now, in example 6, we're asked to use, and in a sense prove, which we already did with a Venn diagram, De Morgan's law. Here our universe will be the alphabet. Set A is the word, or the letters in the word hound, and set B, the letters in the word rock. Verify that the union of A and B's complement is equal to the complement of A intersecting with the complement of B. And you're just going to take notes and follow along with this. Yes, we know this. Now, the union of these would be this. So now we have to take these letters from the alphabet to find the complement. So once we take these letters from the alphabet, we are left with this. Now take a moment, write it down, and I'm not going to try to go through every single step that you would do as you look at this for understanding. Just pause the tape. Now, similarly, when we take the complement of A, as we see here, which are these letters, and the complement of B. Now remember, we're removing those letters from the universe that are in A, and we get this. That's what A complement is. And then B complement is any letters not in B that are part of the universe. So when we put them together now, and we see what intersection we have, that's the symbol, we get the same thing. And again, you're going to have to go through this item by item, and there will be a check, of course, that's coming up. So pause the tape. So we know then the union of A and B's complement is equal to the complement of A intersecting with the complement of B. And there's the proof, and we gave it to you in the Venn diagram as well. Now, here is a self-check. You're given the alphabet as the universe, but A set now is hound, and B set is rock, and they want you to verify. Remember, this is the corollary of De Morgan's law, that the intersection of sets A and B complement is equal to the union of the complement of A and the complement of B. And work it out. See what you get. This is your proof of the pudding, so they say. And there are the answers. And again, pause it to verify De Morgan's law. Now, a little more background for this next item is determining the cardinal number of a union. Now, what does that refer to? Well, the cardinal number is the number of elements in a set. So we see that this set had 1, 2, 3, 4, 5. This set had 1, 2, 3, 4. But there are some repeats. We have to eliminate the repeats. So we want to find the cardinal number. Now, as you look at it, this is the symbolization, the symbols we use for cardinal number. Now, they have these vertical lines that are also used in another part of mathematics to indicate absolute value. But they're not looking for that here. This is just using this as another symbol when we're dealing with set operations. So keeping that in mind, let's move on. Now we found that when we had the union of these sets and we're not repeating items, remember 4 is found in one and the other, 2 is found in one and the other, so we don't count them twice. So now how many elements do we have here? Well, counting 1, 2, 3, 4, 5, 6, 7. We have then the cardinal number, and this is how you write it. The cardinal number of the union of set A and B is 7. So again, we're using things we've already had now, and we're introducing the definition of the cardinal number. And we have to keep in mind that if there's intersection, we don't count that twice, because they would be elements that are in both sets. And here's the inclusion-exclusion principle that states the number of elements in the union of two sets, A and B, is calculated by adding the number of elements in set A to the number of elements in set B, this is important now, less the number of elements that appear in both sets. So through this process of subtraction, we're subtracting the intersection because we're counting them, we can't count them twice. So again, note this formula under inclusion-exclusion principle, that the cardinal number of the union of set A and B is equal to the number in set A plus the number in set B minus those items that intersect. Now, you're adding them, but in a sense, some of these were counted twice. So by subtracting them out, you get the correct number. And again, an example we'll see if you're mastering this. Okay. Here we're going on to a standard deck of playing cards. And we're going to use this a lot here in our next few lessons. 52 cards. And here you need to know this. 26 are red. That would be the hearts and diamonds. 13 of each. And 26 are black. Clubs and spades. Now they're divided into 4 suits. Remember, the clubs and spades are the black ones. Diamonds and hearts are the red ones. Where there are 13 different cards in each suit. There's an ace, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack, queen, and king. And I don't know how many of you know this, but if you don't, you're going to have to become a little familiar with it. And again, take some good notes on this. Of these 12, of these cards, 12 are considered face cards. Now, here you're thinking the face cards are the 4 kings, the 4 queens, and the 4 jacks. Find the number of cards in a standard deck that are either a club or a face card. Now, if I hadn't read this before, I'd have to pause, which you may have to do, and read it again. But let's do a little brainstorming here before we start. And this is not too hard, but let's take a look at it here. So we know that there are going to be 13 club cards in the deck, and these are red. Now, in a deck of cards, there are 12 face cards. But of these face cards, we already have 3 of them here. So to get our total number here, we're going to have to do this first, but then subtract those face cards that are clubs. There's 3 of them. So this is going to be the formula. So we have 12 minus 3 is 9. 9 and 13 will give us then 22 as our cardinal number as we apply this inclusion-exclusion. All right, let's check it out. I didn't use the proper set notation of this, but we were just brainstorming to see if you could follow along. I'm going to leave my work up there too. So we have the union of clubs, which there are 13, with face cards, there are 12. But keeping in mind, there are some face cards that are clubs. So that would be 3 that we would have to subtract. So when we do it, it looks like this down here. And this is our final conclusion. So again, you can pause and, go back, study, See if you really understand it, or again, bring questions in. We're always happy to do some review. All right, well, this will wind up our part 2 of our lesson. Well, let's do this skill check, number 3. Find the number of playing cards that are either even or are diamonds. Now, remember, the word or indicates union. So any diamond, there are 13 diamonds. And then you'll have to, there's 4 sets of cards that will contain these, but then you have to subtract these that are diamonds, so we don't count them again. So we'll give you a moment, or pause, see if you can work this out. And there's the answer, 28. Again, if this is something you had trouble with, bring it in and we'll look it over. Now we'll wind up 2.